This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
Hello, this is Jeremy Jung for Software Engineering Radio. Today I have David Calavera with me. David is the CTO of Netlify, where he and his team are building a platform for deploying and automating modern web projects. Previously, he was a core member of the Docker Engine project. David also built enterprise tools for GitHub and has contributed to numerous open source projects, including Go, JRuby, and many others. Today, I'll be speaking with David about zero-downtime migrations and rollbacks with Kubernetes. After this episode, if you want to learn more about Kubernetes, you can check out episode 246 with John Wilkes on Borg and Kubernetes, or episode 319 with Nicole Hubbard on migrating from VMs to Kubernetes. David, welcome to Software Engineering Radio.
Hi, Jeremy. Thanks for having me.
First, I'd like to discuss migrations, basically defining what they are. So first, what is a migration?
Well, basically, a migration is a way to move software from one version to another. And it really depends on what you're trying to migrate. It could be more complicated or less complicated. It also depends on if you're trying to migrate from an old system to a very new system, which is this case, basically.
Could you give some examples of what's considered a migration versus just a regular change to a system?
Yes. Usually migrations involve changing the fundamental concepts in the system. So in our day-to-day developing software, for instance, we can deploy minimal changes in a continuous manner, and those would just be considered like regular deploys, where your system changes, but it doesn't change the fundamental concepts within your system. When we talk about migrations, we're talking about changing fundamental concepts within your systems, or even replacing the whole system with a different one.
You describe fundamental concepts. Could you give an example of what a fundamental concept might be?
Yes. For example, let's say you have an application that has been built with Rails and it has become a monolith, right? If you want to split that application in different microservices, that would be a fundamental change, right? Like you're changing the way that your application is structured, you're changing the way that the application is going to be deployed, and so on.
When we talk about migrations, are they atomic operations where the entire system switches from the old system to the new system at the same time?
That's a very good question, and it really depends on your use case. This is actually part of my talk where I'll try to discuss concepts like certainty, right? When you perform a big migration, you need to make sure that what you're migrating to has the same certainty than what you had before. For instance, you need to make sure that you know that your system actually has the same behaviors, or you even need to know that how your new system is going to fail, right? And then that's going to affect how you perform that migration. I'm not a big fan of migrations where you basically replace one system with the other, and this is also going to be in my talk where I explain how we perform this migration in an incremental way, where at some point in time, and actually during several months, we were running both systems at the same time. So we can predict what was going to happen with the new system once we put it in production for 100% of our users.
You were describing about being able to predict what can happen with the new system. Is that because you were running both systems at the same time?
Yes, exactly. We run both systems at the same time. We define metrics and pieces of information within the new system that would allow us to make sure that it was working correctly. And we also define some scenarios where we decided that the system was not working correctly, and we designed some strategies to be able to roll back to the old system while the new system was still running at the same time, right?
What are some examples of things that could go wrong during a migration?
Well, there are many things that can go wrong. And this is actually one of my favorite topics, and it's very well described in a book that I always recommend people, called the ETO principle, and it talks about trade-offs between efficiency and thoughtfulness, right? When you're running a big migration to a new system, you need to find a balance between the efficiency of migrating to the new system, because obviously in most cases you're trying to get rid of a system that doesn't work for your use case anymore. So you want to be efficient and do that migration as soon as possible. But on the other hand, you need to be thorough to make sure that the new system is actually going to work in a way that you expect, right? Because obviously when you're introducing a new system, you're introducing new unknowns into your whole architecture.
Right. What was the book that you recommended?
It's called the ETO principle, and ETO is ETTO.
Okay, the ETO principle. And does it walk through, you said the trade-offs between how fast you move towards the new system, but still making sure that it works.
Yeah, it's what it calls the efficiency and thoroughness trade-off, right? You need to balance the efficiency of doing something and the thoroughness of doing that same thing, right? And it's a general book. It's not only about software engineering, and it talks a lot about industries like aviation or like manufacturing and things like that, where actually the stakes are higher, right? And they need to find this balance in a more precise way.
Right. So there's a lot of lessons that we can actually take from other industries that are described in the book.
Yeah, exactly.
When a team encounters errors or failures during a migration, what are their options?
Again, this really depends on the migration and your system. My favorite tools to actually be thorough about migrations and prevent issues during these kind of migrations are applying several patterns that are very well described in many books and articles. But the first one is the circuit breaker pattern, where you have some code running inside your application that's able to decide when to stop doing something depending on the success or failure of this operation. So let's say, for instance, it's very common for network operations, right? So let's say you are talking with a third-party service and you're sending HTTP requests, and this third-party service goes down. So you have in place a circuit breaker that allows you to stop sending those requests to that third party while it's down. And at the same time, it has some logic to periodically retry to see if the third party is back online, right? This actually forces you to think about the consequences of this party going down, right? And then you have to add it to your code logic to make sure that when this third party is down, your users are not affected, or you have some way to actually interrupt the traffic or some way to actually handle that in a graceful manner, right? And that's one of my favorite tools. Everything we do at Netlify that involves having to talk with third parties is protected with this kind of circuit breakers. Different tools that we also use involve, for instance, being able to send the same requests to two different services, like it would be in this case, where after sending those requests and receiving responses, you can compare those responses and decide whether the responses from the new system are what you were expecting or not, right? And then you can decide whether you want to keep sending more requests to the new service or not, depending on the behavior of the system at a point in time, right? And this is actually, I was going to mention that this is a pattern described by Martin Fowler, but I don't really remember. I never remember the name of the pattern, but I can point you to a couple of open source projects that implement this pattern. And one was built at GitHub, and it's called Scientist. So if you go to GitHub's organization in GitHub, there is a project called Scientist, and it basically implements this pattern and allows you to send 2 requests to 2 different systems and then compare the response and decide what to do depending on whether the responses match or not. Right?
I see. And this is something that could apply not just to migrations, but like you were saying, anytime you're dependent on a third-party service or a system you think may go down.
Yeah, or maybe you're changing a big piece of code within your application and you want to make sure that the behavior is still the same, right? You could apply this pattern and use this library for this case too, where you want to make sure that actually changes within your code don't really affect the system, right?
And would this, I'm not sure what the pattern is called, but this setup where you make the 2 requests to do 2 different systems and wait for the correct result from each, does this mean that these services always need to be stateless?
That's a very good question. The easiest way to actually apply this is with a stateless service, right? Because when you're dealing with a stateful services, it means that you're saving some kind of data with both, and it really depends on your implementation. I've used this pattern with stateful services where both branches of my code were like storing data in 2 different places. And then at the same time, when the application read data, it also read the data from those 2 different places, and then compare the data and make sure that is actually the same data that the application is expected.
You would have needed basically 2 data stores, and they would need to always be in sync in order to get the correct answer.
Yes, exactly right. Like, obviously, when you're dealing with stateful services, it needs more preparation, and you need to think about that case, because obviously it might also involve having some kind of migration after you know that the code works correctly or not, and things like that, right? Like it's more involved than dealing with stateless services, but it could still work, right?
I see. Next, when would you opt to apply fixes on top of a migration that didn't go well versus choosing to perform a rollback?
What I try to do in those cases is I try to define a threshold as a expected behavior in error rates, right? And this is also something that you can do with libraries like Scientist, where you can say, if I get this kind of error, this error is expected, and if I get a different error, then it's not expected, and then I need to perform a rollback or do something about it that's different than just handling the error, right? In our case, and it's something that I'm going to include in my talk, the errors were very well defined because we knew what the expected errors are and what the unexpected errors are not. So basically, everything that didn't trigger a success pod scheduling inside Kubernetes was an error that we could not handle, and it was not acceptable. And errors that were caused inside the application that we were running in Kubernetes were errors that we accepted. So those errors, if we saw some of those errors, we didn't roll back. But during this migration, we had to roll back 2 or 3 times because we bump into issues with Kubernetes that we didn't expect it. And in those cases, we roll back to the old system completely.
In the case of your application, you decided that for your own application code, it was okay if there were problems because you would apply fixes on top of that.
Yeah.
But if it was at the infrastructure level, at the Kubernetes level, that the difficulty in finding the problem was maybe so high that it was better to roll back rather than attempt to apply a fix on top of the infrastructure.
Yeah, since we were migrating from a more traditional service that was running inside virtual machines to something running inside Kubernetes, we knew that like every error that we could find that was due to Kubernetes, it was something that we didn't know how to handle yet. And then in those cases, we decided to roll back.
Could you define what a rollback is?
Yeah. So basically, with a rollback, I mean, we stop sending traffic to the new service completely. And then the traffic that we had sent to the new service that failed due to the issues that we bump into was reply on the old service.
I see. Due to the nature of the application, you were able to identify exactly which requests to the Kubernetes setup had failed and then replay them on the old system. And so the customer was never necessarily aware that there was actually a failure.
Yeah, exactly.
What are some of the inherent difficulties in rollbacks in comparison to migrations?
Actually, identifying if you can reply requests or not it's usually very complicated. In our case, we designed the system from the beginning in a way where we could actually identify those requests even before we decide to migrate to a new system. We kept track of those operations. So for us was not as hard as to identify which requests were failing and why, and whether we could replay them on the old system or not. But usually, the challenges when you decide to do a rollback from a migration like this are that you need to deal with this uncertainty of what to do with the operations that fail due to the new system, right? And if you use tools like circuit breakers or libraries like Scientist, those tools force you to actually think about rollback situations, right? So like in a way, they help you define what to do in case of failure, which is always very useful when you need to do rollbacks. Right?
How would you say the risks of a rollback compare to a migration?
I think if your errors are well defined, the risks are lower because you are going back to a system that you already know. But you need to make sure that you understand the implications of errors in the new system. Right?
Other than the types of operations or identifying the operations that need to be dealt with when they fail, are there any other things that are more difficult with a rollback? Like, for example, anything to do with a database or something like that?
Yeah, and like that really depends on your system. And obviously, the different systems will have different challenges during migrations and rollbacks. But that's more depending on which kind of application you're dealing with, right?
Some organizations have a philosophy of always applying fixes and never rolling back. Do you have any thoughts on this?
I think it depends on your velocity and how fast you can apply fixes versus how fast you can roll back to a state that you know that is safe to roll back to. If you have a very well-defined continuous delivery pipeline and you're capable enough to identify errors and apply fixes as fast as possible, that could be a very good strategy to always apply fixes and move forward. If you're not so sure about your continuous delivery pipeline, or it takes more time to actually release new code than rolling back to old code, then in those cases it's probably going to be easier for you to roll back. It depends on your infrastructure and how you architect your release management processes.
And in the case of the migration at Netlify, the troubleshooting or debugging the problems in Kubernetes, you made the decision that it would require too much time to identify the problem, and that's why a rollback was appropriate.
Yeah, since we were migrating to a system that was still very unknown for us as a production system, we decided that actually stop using the system completely was safer than trying to trace the causes of the errors and try to fix them while the system was still running, right?
I'd like to talk about downtime. How would you define downtime in the context of a migration?
Downtime is basically time that your users are being affected by an issue, and it doesn't matter which kind of issue. Like there are many ways to have downtime. In the case of Netlify, for instance, we define downtime at the CDN level if a customer cannot serve their web project. That's a downtime. That's a very traditional way to identify downtime, where it's like, well, if a website is not accessible, there is a downtime, right? But we also identify downtime. Actually, was one of the reasons why we did this migration, as the process where one of our users tries to deploy the website and they cannot do it because our system is down, right? So that we also define downtime in that regard. So during a project deployment, we allow users to run some arbitrary code so they can execute tasks to build their projects. And if they cannot do that at any point of time, that's downtime for us too, right?
What makes a zero downtime migration or rollback more challenging?
I think the challenge is identify how to make sure that users don't actually perceive any issues during any point in time, right? And in our case, for instance, if someone tries to deploy and something is broken inside our system and they cannot deploy, we need to do something to ensure that those deploys go through, right? So if someone tries to run some code to build a project and there is an error because our infrastructure is down, we need to make a decision about what to do with those errors, right?
Right. What are your thoughts on systems that have planned maintenance windows versus systems that perform zero downtime migrations?
I don't think I have opinions. I'm curious about reasons why people decide to have maintenance windows, and I'm sure there are very good reasons. We actually, completely unrelated to this migration project, we had a maintenance issue where we stopped a system for, I think it was like 2 minutes. But during those 2 minutes, actually, we didn't get any requests to that service. So actually, no one noticed it.
Oh, okay.
in that case, was because we're trying to migrate an API from a third-party provider from one version to another, and it's a stateful service, so we couldn't have mixed requests between one version of the API and the other. So we needed to actually cut all the requests to this third-party provider, so to ensure that we didn't get any mixed requests between versions, and then start all the new requests with the new version of the API, right?
I see.
So in that case, we had a very small maintenance window, and we actually set it for 5 minutes, and it was shorter than that. I think it was like 2 minutes. But in that case, that forced us to actually have that maintenance. And it really, there are use cases where like you actually need to do things like that, and all of them are usually justified. I think at this point in time, no one actually wants to have a maintenance window that affects users and prevents people from using your services, right?
The reason I asked the question is more determining when it makes sense to do kind of like what you did, where you make the decision that the system is just going to be down for a few minutes or whatever that time frame is, versus there may be cases where attempting to perform a migration without downtime is actually from an engineering perspective, very difficult. So when does it make sense from a cost perspective to just sort of take the hit and say like, okay, we're going to be down for 10 minutes versus spending 40 engineering hours making sure that we do a migration with no downtime?
Yeah, and it really depends on each case, right? I don't think there is a general rule to say like, oh, this kind of operations need to be always like require some downtime or some maintenance window, and these other ones don't, right? I don't think there's any general rule to apply there. It really depends on each case.
Next, I'd like to talk about the app that you're migrating to the Kubernetes system. What does, at a high level, the application you were migrating do?
Yeah, so it's a very interesting story because it's not a traditional stateless application, which is basically this strong Kubernetes workload. This is the system that we try to that we migrated to Kubernetes is the system that runs the arbitrary code that people give us to build their projects. So in the old system, when we got a request to build a project, we sent that request into a queue, and then there was one of our services picked messages from that queue and then scheduled some Docker containers and run that code inside Docker containers, right? And for different reasons, we had several issues with that, and one of the most evident for us was that we didn't have a nice way to scale that service. So if for some reason we get an insane amount of requests to that service at any point of time, it was very complicated for us to actually scale that in a way that didn't affect users, right? So for people in those cases, basically they experience delays deploying their websites, right? And we did some investigations. We had several alternatives. And we decided to go with Kubernetes after several tests because the scheduler did most of the heavy lifting for us. We did some tests and it worked pretty well. And it also gave us the autoscaler capabilities that we didn't have. So if during peak hours we needed to schedule, let's say 30 pods or 50 pods, the autoscaler would do that automatically for us. And during non-peak hours, like let's say during weekends, the autoscaler would decrease the number of pods in the cluster for us directly, right? So that was something that was very appealing for us. So we replaced this old system where we sent messages to this queue, and then there was a service running and like listening for messages in the queue, to a system where we send messages to the Kubernetes scheduler to schedule new pods, and then the scheduler basically schedule these pods with a software that we implemented to write the pod definition into Kubernetes, and then execute the user's code inside those pods, right?
The original system you were using that was running on VMs and using containers, how were you performing the manual scaling?
So manual scaling was basically us incrementing the number of VMs that were connected to the queue.
Did you have custom software you wrote to determine what your load was and how much to scale?
We actually did not. Like, we had some metrics and we had some alerts, and we knew when, based on those metrics, we knew when we had to scale the system, but it was still very uncertain to us when we had to do it, right? It was a very reactive process where we got these notifications, and then we were like, okay, now we're gonna increase the number of VMs, but then we never knew when we could decrease the number of VMs. Or like, obviously we also had the scenarios where we increased the capacity of the cluster and then we didn't need it, right?
You had some metrics and some alerts, but ultimately it was engineers on your team that decided whether to increase the number of instances or maybe even decrease the number of instances.
Yes. Yeah, exactly.
At kind of a high level, can you describe what Kubernetes does and what pods are in the context of that?
Yeah. So Kubernetes is a distributed system that takes job definitions, and then given a job definition, it could be a job definition could be just run this web application or basically run this process, which is it could be just a Go process or a Rails web application or like any kind of process that you want to define, and then the scheduler decides to put this process into what are called pods. And a pod is basically a group of containers together. So a pod is usually the process that you want to run, that you gave the scheduler in the definition, and then some sidecar containers to help that process. For instance, you have a container to do login aggregation, or you have a container to extract metrics from the process that you are running, and so on, right? And that's a pod is basically a group of containers that work together to make sure that your process actually works as expected.
You described how Kubernetes provides things like logging aggregation or extracting metrics. Were you using the same software to do that you were with the previous system, or was this something new?
No, it was the same. It was the same software. We run the same infrastructure for logging aggregation and metrics than we did before. But the only difference is that we had to architect it in a different way. But at the end, all that information ends up in the same systems.
I see. So for the most part, the actual application code you wrote was untouched with both architectures. Is that correct?
Yeah, that is correct. Yeah.
Were you making use of a vendor's implementation of Kubernetes, or were you managing the instance yourself?
So we use Google Containers Engine, and that's something that we talk a lot about it. There is always a trade-off between buying versus building, and we could have managed it ourselves, but then we would have also introducing more unknowns to our system since we had not used Kubernetes at this scale before, right? So managing ourselves the cluster would mean also that we would need to manage etcd, and we would need to manage the whole lifecycle of the cluster and so on. And since we are still a small team, we decided to actually go with a provider that could do all that for us, so we could focus on our application and actually deliver like the service to our users.
For developers that work at Netlify, did this migration change anything for them?
It did. We had to change a little bit the way that we deploy these services to Kubernetes, because before, when we had them in virtual machines, they were like long-running services. So the deployment process was to put the new binaries in those virtual machines and then restart the services in a graceful way. And then when we migrated to Kubernetes, we moved to a system where those services were not running continuously all the time. So the Kubernetes scheduler starts the process, and instead of being a long-running process, it's a short-running process that still does the same logic, but it does it for every time we schedule a job in the container, in the cluster.
When you decided to perform the migration, how did you prepare to perform a migration without downtime?
Mm-hmm. Yeah, so most of the preparation came from ensuring that we could roll back to the old system and that we could extract enough information for us to understand why the new system was not working. And we put in place a system with the tools and techniques that we discussed before, so we could decide what to do when we bump into issues with the new system. And that was most of the preparation that we did for this migration. It was basically ensuring that no matter what, like, people could not be affected by us trying to migrate to the new system, and we had enough information to actually debug the new system and find the issues that we bump into.
Did you choose a small percentage of users to migrate, or how did you start the process?
Yeah, so we started just using it ourselves. So we everything that like every single web property that Netlify owns runs on Netlify. So it's very good for us to actually to be able to test these things, because we have many projects that actually run on Netlify. So, and it's not only specific for in this case, but everything we do, first we try it ourselves to make sure that it works, that we're satisfied with it, and that everything works as expected with our use cases. And then we use feature flags to be able to release, or to be able to move traffic from one system to another in a controlled manner. So at first we just move 1% of the traffic to this new system, and then observe what happened. And then if everything when everything was correct, we increase that percentage to 10%, and then and so on, right? And we actually at some point we actually increased the traffic to 100%, and we had, after increasing the traffic to 100%, we bump into issues that we had not bumped into before, and we had to actually decrease the percent of traffic to 0, and then start over, right?
I see. So you kind of dogfooded it yourself, and then gradually increased the users that were migrated to the new system. But it wasn't until you had actually performed a full migration that you started to experience problems.
Yeah, I mean, we experienced different problems, and actually each problem was manifested in different states of the migration.
When these problems were happening, when you were getting them from your metrics, what would a user have experienced during this period?
So for a user, they will see one of the deploys for their projects fail, and automatically, as soon as the deploy fail, a new deploy was scheduled, like right away. So for them, what they will see is that something inside Netlify would fail, and then Netlify itself decided to trigger a new deploy right away. And when we triggered this new deploy, it was triggered in the old system, where we knew that deploy should work as expected, right?
I see. So for a user during this period, they most likely would not have even noticed that there was a problem happening with the migration.
Yeah, exactly.
Well, so you said there were metrics that you were following. Was there a very large percentage of builds that were failing, or was it just a small amount? Or
we bump into a couple of issues where a big percentage of builds start failing because of disk saturation inside the containers. So since we allow people to run arbitrary code, and this code usually involves creating many files, and we bump into issues where people would saturate disks, and then builds start failing. And that actually, we only discovered that when we turn 100% of the traffic into the new system. So in that case, like, a large number of people would actually bump into that issue, and then their deploys were automatically rescheduled. But then for other issues, like, not many people actually bump into them, and some issues also were only involved that the deploys were delayed. So instead of being deployed like in 30 seconds or less, maybe it was deployed in like 3 or 5 minutes, 3, 4, 5 minutes, something like that, right?
And as you were seeing these metrics occur, I guess in this case, like you said, it was oversaturation of the disks. In most cases, did you know the source of the problems, or were you just aware of the fact that there was a problem?
most of the cases we didn't know the source of the problem, and we had to do some investigation in that. And the case of the desaturation was actually very funny because we realized that this saturation issue caused a problem with Docker that I tried to fix a long time ago when I was still working at Docker, and I never fixed because we never knew why it was. Like we had reports of people saying that some commands got stuck and actually like caused segmentation faults in Docker, but we never knew why. And we tried different things, and we never fixed it. And future versions of Docker actually work around this problem because they rewrote the whole engine when Docker moved from having the container scheduler inside the Docker engine to use containerd. The whole system was rewritten, and like that problem disappeared. And I think until even today, Google Container Engine still uses an old version of Docker that still has this problem, right? So when the disk gets saturated and Kubernetes is trying to perform some health checks, it uses a command in Docker called docker ps just to check if the containers are running. So the disk was saturated, and then Kubernetes was trying to run docker ps, which caused docker ps to hang forever. And then Kubernetes decided to kill containers because it thought that they were stale. Right? And it was very funny because like when I was working at Docker, like we never knew why docker ps could hang at all.
Yeah.
And then when we bump into this, I was like, oh my god, I've seen this issue and now I understand it.
So is it like you were trying to search for a solution and then you came across your old issue you had posted or something like that?
Yeah. Many people, like there was a long thread on that issue because it was open like I think it was like 2014 or something like that, and many people have bumped into it. And the description was basically docker ps hangs for unknown reasons.
Yeah, it's very general.
Yeah, so like different people have bumped into it. Different people have tried to find the root cause. No one knew like why it happened, but we knew it happened. And then at the end it happened to me, and we were able to understand it. But at this point, Docker doesn't use the same code to do docker ps, so like that's not a problem anymore.
So when you were performing the migration to Kubernetes, that code that had this problem doesn't exist anymore?
No, it does still exist in all versions of Docker. And Google Container Engine still uses a version of Docker that's affected by this bug.
Oh, I see. So just to make sure I understand, so you were saying when the disks get saturated, in this case, it's because a bunch of files are being created within the same container. This causes some kind of problem with Docker. Does the container become unresponsive at that point?
I think that the container becomes unresponsive. I'm not completely sure about that. But docker ps, which is the command that lists all the containers that Docker is running, becomes unresponsive. And Kubernetes uses docker ps to do health checks inside the cluster.
Right.
So Kubernetes thought that something was wrong in the cluster, and it ended up restarting the Docker daemon inside the cluster, right?
I see.
And then when you restart the Docker daemon in this specific version of Docker, because it was still an old version, it killed all the containers that were running in the cluster.
Because they all, when it would run docker ps, it would just hang, so it would assume that all the containers must be down.
Yes, exactly.
I see. How did you identify these problems after you had decided to do the rollback? Because the problem, you said, only manifested when you were at 100% load.
Yeah, what we did in those cases was we started trying to reproduce the problem with our own properties and our own projects. And since we knew that it only manifested with 100% of the load, we tried to generate that load for our own projects. So we ran some experiments with our own projects to be able to generate the same amount of load that we saw when the disk was saturated. And then when we managed to reproduce that with our own requests, we were able to trace it into this issue.
I see. When you decided to do the migration, did you perform any kind of load testing on the containers beforehand?
We did do some load testing, and everything looked correct. But obviously, the amount of load that you can expect always changes.
Right.
And like we can never predict what users are gonna do during traffic hours and when the system is in production. But we did run some load testing before we started the whole migration to make sure that the Kubernetes scheduler could actually handle the load, and everything looked correct to us. We didn't actually bump into any of these issues that we bump after the migration.
So after fixing this issue, you performed a second migration attempt. Did you encounter any issues after that?
We encountered an issue with the autoscaler, and we end up rolling back the version of Kubernetes that we were running, and that seemed to fix the issue. And we end up just using an old version of Kubernetes instead of the newer ones. And I think the most recent one solves that problem, but we haven't tested yet.
And this problem with the autoscaler, you didn't encounter that with the first migration?
Mm-hmm, exactly. And it was also an issue that only appeared when we started running all our traffic through the cluster. And it was because the autoscaler was not actually scaling the size of the cluster correctly. So in this case, users would see delays on their deploys, and it basically was that the queue that the scheduler keeps in etcd was growing, but the autoscaler was not actually increasing the number of pods in the cluster accordingly to the scale. So people would experience basically delays on their deploys, but it was not something that was not critical, because at the end, like, all the deploys actually went through. And
right.
We only experienced it when we tried to update the version of Kubernetes. And then right away, we decided to just roll back the version of Kubernetes, and that seemed to fix the problem.
I see. So you did the first migration on a version of Kubernetes. You rolled back, fixed the problem where Kubernetes was doing the health check and seeing all the containers were down because of the command failing. Then you addressed that issue, and then you migrated again. But on the second migration, you used a newer version of Kubernetes?
No, we migrated again, and then that it was stable for some time.
Oh, I see.
And we were already running in production, and then at some point we decided to update the version of Kubernetes, and then it's when we bump into this new issue. And then in this case, we only had to downgrade the version of Kubernetes, but we still had the old service running, and we did move some people and some traffic to the old system while we were trying to figure out why it was not working correctly.
I see. So when you decided to try upgrading Kubernetes, you still had the old version running the VMs available?
We kept the cluster around for some time, just as a precaution.
Mm-hmm.
And actually, it was a good idea at the end. But then after that, after solving all that that other issue. Again, we kept the cluster around for a while, and then we just remove it.
Mm-hmm. How long did you keep the old system before deciding to close it?
I think it was between 2 weeks and a month.
After you had let the system run complete with all traffic going to the new system, then you made the decision that it seemed stable enough to shut it down.
Yeah.
Looking back, is there anything you would have done differently to try and catch the failures you had during migrations?
It's hard to say. At the end, it took us longer than we expected to do this migration, and we could have taken different approaches instead of this one. But I don't think the other approaches would have been just incident free. We just don't know what would have happened in those cases. And even though it took us longer than we expected, the system is much more stable than it was before. Right now, we also have better information about what happens inside the system, just because Kubernetes provides much more information and insights than we have before. And we have also since we are more confident about the system and we have more information about it, we can actually make better decisions. Like in the last few months, we have seen the load of the traffic increasing a lot, and if we had been in the old system, our reaction would have been basically to just increase the capacity. But now, since we have in a better position to do auto-scaling and we have more information, we can actually stop before reacting and actually think about the consequences and think about why the system is behaving in the way that's behaving and so on.
And now with Kubernetes, you've in a way outsourced the decision on whether to scale up or down. That all just happens automatically.
Yeah, exactly, right. And since we know that that's going to happen, we can actually look into the data and see why it's happening, and see and actually we're better informed about when it happens and why it happens, right? I think it was about a month ago, we had an issue with a customer that was trying to use our system to mine Bitcoins, right?
Oh.
So in that case, the autoscaler just kicked in and it started increasing the size of the cluster. And then we could go in to see what was running inside the cluster and what actually triggered that autoscaling. And then we saw that it was someone that was trying to mine Bitcoins in the system, right? And we could actually spend the time into looking into it and seeing why it was happening. And actually, the rest of our customers were not affected because the system just increased the capacity, and every single deploy went through, and nothing happened for any other customers. But in the old system, that would have caused a lot of delays for other customers. It would have caused us to actually try to autoscale the system manually. It would have caused us to actually having to do a lot of things that we don't have to do now, right?
Yeah, so in this case, it seems like Kubernetes actually helped you prevent yourself from becoming a Bitcoin miner.
Yeah, exactly. And it's because since we know that the system is going to handle doing all these automatic operations for us, we can actually spend the time into looking into the reasons why this is happening, right?
So overall, it sounds like Kubernetes allowed you to use your resources more efficiently. Mm-hmm. It also gave you auto-scaling. It also gave you more information, more insight into seeing where problems are or why things might be scaling up. Overall, are you happy with the decision to migrate to Kubernetes?
Yeah, we're happy. Yeah.
Do you have any recommendations for people who are considering a migration to Kubernetes?
There are a lot of resources around these days. A guide that I'd really like is called Kubernetes the Hard Way. And it explains how to actually set everything up. And it's a very thorough deep dive into Kubernetes. And it helps you understand a lot of the system how it works. And I think that's very fundamental, fundamental aspect to actually move to Kubernetes, even if you decide not to manage it yourself. But that can also help you make those kind of decisions, right?
Mm-hmm. So that's the book that you maybe read initially when you were making your decision?
Yeah, it's not a book. It's in GitHub. It's in a repository, and it's a guide. So like in a GitHub repository, but it's a very good read.
I see. Okay, we'll be sure to put that in the show notes. Are there any general recommendations you have for teams that are undergoing zero-downtime migrations or rollbacks?
I would recommend people to try to understand the reasons why your system is failing. Also, try to understand the reasons why your new system might fail. Yeah. And actually having those pieces of information will guide people into writing their software and writing software that is more resilient to failure. Right?
So just in a general sense, make sure that you employ tactics like, for example, you had I think, what was the term? The circuit breaker pattern, or employing a pattern such as the one you described where you send the same calls to do two different services and see make sure that both succeed, and just give you ways of having more information so that you know why there's a failure and you'll be prepared if there is a problem.
Yeah, exactly.
Finally, how can people follow you and see what you're working on next?
I'm on Twitter. People can follow me there. My handle is my last name, Calavera. And I'm also on GitHub with the same handle. And then if people have questions, they can email me to david@netlify.com too.
And for people who want to hear more about the migration at Netlify, you have a talk coming up. Could you just say briefly what that's about?
Yeah, I have a talk coming up at VelocityCurve in San Jose. It's next Wednesday. The talk is basically the story about this migration and how it went, and also like basically the same concepts that we talk here today in a talk. I'll probably try to also publish a blog post after the conference, talking a little bit about all these too, so people might be able to read it online.
Great. So when this show airs, the conference talk, I believe the video should be posted by then. So we'll be sure to post those in the notes as well.
Cool.
David, thank you so much for coming on the show.
Yeah, thanks for having me.
This is Jeremy Jung for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.